Hiya folks, something a little bit different has come in. We've got, well, kind of different, kind of part and parcel, but we've got, this is a lump of a set of Simba discs. There's a few problems with this arm that's come in. Number one, these holes are worn here, put your finger through. They're not going to be too bad to do. What I've got, I actually found a piece of material. If I come over here, I had some very heavy walled tube for another job. It's not actually tube, it's actually seamless. I think it's probably some kind of barrel for something, but it's a bit of ENA. It's nice and tough. So the centre isn't the right size. OD is pretty much spot on for what I want to get slop in there. So what I can do is just bore this tube out, bigger OD on there, clean it up, weld them in the holes. Let me just go back over there and weld them back in these two holes here. Shouldn't be a problem at all. Now the more complex issue is down here. These are a pivot point, so they have this shell goes on here and a whole lot of hinges which the wheels are attached to. So if I put it on there, that's a brand new shell. What we've got is a fair bit of slop in that, and it's worse in the other planes than others, obviously where it's been moving about. The other side's actually not too bad, you'd almost get away with that one, but while we're doing it, we're going to do two sides. So the question is, I was trying to think of a clever way of doing this. There isn't really any way that I can swing that. I haven't got a big enough lathe to start swinging that about. I don't know many people who have. And then you've got the issues, you've got to weight everything up because it's crank, and it's just going to be a lot of ball ache to do it like that. So, what we're going to do. Firstly, I was going to make up two new ends, cut them off here, nice register machined into it, drill a hole into the material there. This will all come more apparent as I do it, and have done with it. Priced up the material this morning for 400mm of 100mm bar, so 100mm diameter, 400 long, which is what I'm roughly going to need to do it. Quotes were coming back at 400 to 500 quid, which to build something up probably about 2 or 3 mil aware seems a bit on the excessive side to me. So I've decided, actually, after I thought about it a bit more, I mean, I've built lots of shafts up in the past. It's not a problem building that shaft up. What we'll do is we'll use stainless steel rod and fillet here when we do this, and we run some stringers in it and we'll just build the shaft up. Okay, so what we're now going to do, we're going to cut it off here. We're going to reuse this. We're going to build it up, and we're going to make a little fixture up so we can put a dowel or a plug in here. So we get this dead accurate. This one we can obviously do when it's on the lathe. So everything will line back up. Nice big bevel on there. Weld it in. Job done. Right. That's the theory anyway. Let's start the practice. So first job is just turn out this. I've got a piece of scrap material here. Bored to about 80mm. So first job is just bore this out to 100mm, which is ideal for the job. We've actually probably got a drill that would almost be like for 100mm. I think I've got 100mm to the ground, but hey ho, we've got a boring wire out there, so we might as well just put a few cuts in and get it bored out. So we're just going to put our last cut through here on this little fixture we're making up, then we'll try it on the shaft, see how it fits. So we've made our fixture up, or part of the fixture anyway, pretty much bang on the money. The paint is grabbing at the moment. There's paint on all this, so we might even give that a little bit of relief because it hasn't got, it is only for lining everything up, so we don't want it too tight because we're going to jam everything and not get it off. So I think we'll take that 10 microns or something just to give us a bit of wiggle room on there, and see how it fits there. Right, after knocking all the paint and the crap off there was about 30 microns of paint or so on there, and probably more than that actually. This ring I've made 3/4 of a mil oversized, so as you can see, nice easy fit on and off. That's all we really need, just line everything up as a fixture. Now this will double up. What I can do with this now is use this to mark out, because I'm going to cut these with a grinder. So I'm going to put a set distance in between here and here, and then I'm going to cut round, just mark off. Unfortunately, I mean, it'd be nice to put it in the saw, because then I'd obviously get much squarer cut, less kerf, etc. Because I'm going to have to make allowances. So I've got 3mm drying this, so that's going to be 6mm as well. When I set everything back up again to weld in there, I'm going to make a bit of allowance for that as well. But you know what? There isn't really any other way of doing it, so I'm actually going to have to just mark it out and cut it with a grinder. So we're just in the office. We're just going to draw up these this little fixture shape, so we can cut this out in a minute. Dead simple, just draw it up on CAD. Take it from there. So here's this little fixture just drawn up. Eagle-eyed viewers will notice that I've actually made it so the circle's cut out separately, because what I want to do is obviously weld this fixture in there and then bore the hole through so it's dead in the centre of the fixture separately, and I don't want this bit swinging around on the lathe. It could be done, but it makes everything unbalanced and rattle, and it's just nasty. And so best thing to do is just leave it a bit separately, and then I can just weld this in afterwards, just tack this in afterwards. Okay. So we drop this little fixture up onto SheetCam. SheetCam really is a great little program. I'm just quickly, briefly say about it. Anything we draw up in AutoCAD then has to be converted into what's known as G-code to be used on the tables and machines, etc. So what this program does is just basically just takes you a line drawing, any outline drawing, and you manipulate it on. This is the actual, if I can just show you here, this is the actual material. You actually just put the size of material in. This is your table machine, your working options, and this is the piece that we're going to cut out. So nice and easy, literally just put it in there and it will cut it out for you. Then converts it to a format known as G-code. The program itself is $80. I think it was something like $80 for an unlimited license. So, you know, if that was a commercial piece of software, that would be in the thousands, but somebody who's written this as a sort of small user, home user type program, as I say, it works really well. I've used it now probably for 20 years. It occasionally gets confused, but as I say, for an 80 quid piece of software, you can't really beat it. As you see, we put a line on here. This is our fixture. Just got a picture of this. I'll show you how it works. We'll cut the ends off. But this is our fixture made up. So we put an 18mm. As you can see, we've got a shoulder on there. We put an 18mm hole through. We're going to go 16, but actually 18 will work because we've got a 18mm rotor broach. So we'll put some 18 bar in there as the plug. Bracket on for obviously sit the mag drill on. So what we can do, well, I'll show you that in a minute. Right, we're going to tackle this with a 9-inch grinder now. We're going to cut down this line here, hopefully chop these off reasonably square. It's not the end of the world because it's the same bit going back on, but you know, we like to do the best we can. And yeah, we'll show you how that fixture works after that. So yeah, we just put one on this one, and the other side of course will be number 2. Let me just show you, that's fairly warm, this fixture. So the fixture will go on at the end of the stub like this. So when it comes to it, so we want to get everything back in line. That fit on there, which is a nice tight fit. This will be tacked. We will tack that onto the end there. Plus hole in there. Mag drill on base. Perfect centre. On these, what we're going to do is we're going to put a 308 L rod. I don't do a lot of stick welding these days, but they're excellent rod for building up with because they'll leave a stainless finish on there and it'll be nice and machinable, but it won't be go rock hard and brittle. It won't be a sod to machine. It will machine up quite nicely. So this is what I've always done in the past. Always use 308 L. I mean, we're not building massively. I mean, this thing isn't that worn. It's not that terrible, but you know, you've got a few mil on here that you want to build up. So the process is we'll just run down, string of beads down here, down here, down here, one at a time. When we've got enough of, then we will machine it. We might have to put a little bit more in because we might have the odd hole and the odd divot, but we machine it back and that'll be the job done. We'll be ready to reassemble them. We've got our little launch set out, 150 amp set, plenty of run this. We're not after any penetration, we want to actually just let this stick on the top really. Airfed bucket on, because particularly with these stainless steel rods and hard facing rods, they're full of lots of nasties. I mean, always wear a airfed bucket anyway. If you do this sort of work, it will just screw you up, otherwise you'll end up with cancer or something. So none of us want that. So you know, the kit's out there now, wear it. So we're going to just build this up, stringer technique, put this on the surface, and I'll show you when we've got some built up. Okay, so we just built a few stringers up in there. As you can see, they're laying in quite nicely. One of the nice things about these 308s as well, I mean, stainless, the slag was, yeah, just literally bubbles off. You don't need to ship stuff at all. As long as you've got your amps and your speed right, I mean, it will just lay down. They're a real pleasure to use. As I said, I'm going to finish this off now. I'm going to go all the way around, build up, build up, build up, build up, build up until we're ready to machine it back on the lathe. So we set this up on the lathe. I've just put a quick roughing cut through here, as you can see. Just to start taking them off. I mean, the main thing is to just take your time when you're doing these welds. I mean, it machines those rods with the silicone in them. They machine quite nicely. They're not a hard weld, so you're not going to be too brutalist on it. But with the carbide tip pipes, just take your time so you don't shatter anything. Don't give a lathe too much stick, etc. And they will machine off fine. So we're just going to put another cut onto this one. As I say, once you start getting into the weld, you can start to go a bit more detail, but you don't want to be knocking all your tips off on this sort of these big divots, etc. we're just taking the final pass, final cut off this. It's all looking pretty good. There's a couple of little divots in it, but that's absolutely fine for what we want. We'll clean the end up when we change the tooling, but what I want to do is get the next one roughed out first, and then we can finish these off with the whole thing. Okay, so we've got these parts all made up now. This is the bulk of the machining is actually done. I've got drill holes and start putting the welds in. As you can see, this stainless filler absolutely machines back lovely. I mean, you've got a perfect finish on here. Odd little divot here and there where I didn't build it up quite enough before I machined it back. But, you know, as I said, we're on something that moves quarter of a turn, you know, 50 times a year. It's going to last a long while. It's going to last a long while. On the back side of it, so we've machined this up, done this lump. On the back side of it, we started putting our I've just put a bit of a chamfer on there ready for welding. It wants more. It will want quite a nice deep groove to when we actually start to weld in there, but I'll show you the welding when we actually come to it. And I've machined this. So we put this hole up. I've seen to hold this one ready. Little dowel pop in there. That's for our alignment, and then we can dowel the whole lot up put a hole in the other side so this dowel matches, and that's how we're going to keep everything square when we're welding it. Proof is in the pudding, of course, is have we got them tight. So here's the other one sitting in the bearing housing. Let's pull that one out for a minute. As you can see, bit of rust in there from that housing. I slide this one in. Pretty much 100% in there, look. You know, we want a little bit of play, obviously, because it's going to be packed with grease, so there's a nice grease ring in there. But I mean, we haven't got that play that we had before in there. What I've done is drop that. It's about 55 microns undersize. So we ran this 5 microns on the side. When we finish this off, we did sort of a final cut with about 5 microns on the side, just to give it a little bit of slack. As I say, this is all big, chunky stuff. So you're not going to want to be getting massive tolerances in, because you'll never assemble anything. If anything's slightly out of square, you're not going to get it together. This is absolutely, I would say, pretty much as good as it gets. So our next job is going to be to start to put these into what we've got to do next is use our little fixture that we made before. I'm going to move this up onto the bench. To drill our hole to receive our dowel, which is going to line everything up while we're welding it. Let's just get you on the side without being too shaky. So there's our little fixture, which will sit on there, ready to tack in. I'll show you some better pictures of this anyway at a later date. And then we're going to put our mag drill on there, obviously, drill that in, and then everything should line up. We're going to have to, I mean, what sort of size of groove we're going to put into here? We're probably going to have to come back nearly an inch, I'd say. Good 20 mil plus. So really get that filler into there. We really want to bring it down to about, again, because we're running on the leg length, so we really want to come down about 25 mil into it, so we can really build that and get full penetration into this, because we want this as strong as the original material, and it will be. Once it's welded in there, there'll be no reason why this isn't as strong as the original parent. You know, it's not going to go anywhere, but do the job right and do it once. We've clamped this little fixture on here. I just wanted to check that it's correct in the X and Y, which I've already done actually, but it's 35 mil out, so we're happy with that. So what you want to do is just check these two planes here. So you check at 90 degrees. So actually I've already scribed 2 lines on there roughly, so there's a line there and a line there. And if you check those 2 planes, you know that it can't be rocking back and forth like this or over. Let me just explain that a little bit better. So you can't be rocking this end out, that end out, or the other way, other direction. So you just want to check that before we start drilling holes. But anyway, we've clamped it up. It's clamped on there. Next job, we're going to get mag drill out. We're going to drill a hole. We put our mag drill on, 18mm hole, lined everything up. We got a little bit of suds here in the bottle, which is there's just a squirty bottle I use, just a little bit of suds because it won't run out. It has got an automatic feeder on it, but it won't run out when it's like this on its side. So, right, we're ready to commence to drill this hole. We'll go a touch deeper on that in a minute, but I'll just clean this drill bit up. You don't really want a wet swarf in there. Make sure we've got plenty of lube in there. I think I did forget to mention, of course, being a rotor broach cutter, we're going to leave an insert in there. So we could probably, if we wanted to be a bit animal-like, we could probably break that out. We could run another drill in there, but the easiest way is going to be those dowels that we made just to hollow them out and drill down the centre of them, hollow them out so it takes the dowel. As I say, this is only for location. It won't add any strength to it. It's just to locate it literally while it's welded and keep everything in line. So we're taking our drill off. We're just going to take these clamps off. Fixture away. And there is our hole. As you can see what I'm saying about the leaving the tang in. Well, we're not going to try and get that out. We're just not going to bugger about with it. It's not worth it. We've dowed these two up. As you can see, putting in there, we use, I'll show you a little what we do anyway to line, make sure that's all properly lined up when that's finished. But as you can see, I'm pretty happy with how they're sitting. We've got some big preps to put on there. I'll just show you what we did to make that dowel fit, so that it comes out. And as you can see, we've obviously got that circle that's been left by the rotor broach, and all we did was board this out so this fits in there. So that fits in there nicely, and then that will of course fit on the front like so. That's all good to go. So I'm going to put some prep on there. We'll probably start off with a 9-inch grinder. Take the big off first because we want to put plenty of prep on there because we want to get a nice little weld in there when we do it. So we'll start off with a 9-inch grinder, work our way around with a 9-inch grinder, and then we'll finish off with one of the lighter discs. We've done our prep on this. I hate doing prep. I really hate putting V's in. I don't know anybody who enjoys using 9-inch grinder stuff. But we did a 9-inch grinder, and then we used one of our flat discs, which I've talked about before, just to finish off with not flat disc, a flat type disc. 3M were doing, and I'm not sure what the technical name of them is, but they have a backing pad and they have a front pad anyway. Here it is. Here is the, so we can see this. Put this in, nice big bevel on here. What we're going to do, we're going to, this is some TIG rod. So I want to put what's known as a root gap in here as well. So we're going to put a gap between these two faces as well. So what we'll do is keep our root gap nice and even. We'll use a piece of filler rod, TIG filler rod. This one's a 2mm filler rod. So we're going to put 2mm root gap in here. I think we could have gone a little bit bigger, but even so, eagle eyes will know that we want about 3 mil a side, so we're going to lose about 2 mil off the overall lip, which I don't think in the grand scheme of things is really going to affect the overall performance because of the curve and the cut. And then, what else we're going to do? We're also going to clamp these pieces of angle. This is a pipe fitter's trick, so we're going to clip these pieces of angle here. See them? We're going to clamp these either side. I should show this once it's all ready to weld. We're going to clamp these either side, and that will keep everything dead straight and in line. We've already got a plug in the middle. We've got these on the side, so we will be, should be, pretty much cock on where we need to be. We're going to tack. We're going to put a few little tacks in there into the root. We'll probably grind them back before we start welding it properly. But once we start welding it properly, I want to give it a bit of preheat. It's a big old bit of bar, so it wants a bit of heating up. So we're going to just bring this up, warm this up probably to about 100 degrees, something like that. Yes, as I say, I'll clamp these bits up and I'll just show you this last bit of prep. Here's everything just prepped, ready to tack this in there. As I say, I've got my staple shaped piece of TIG wire just to put this root gap in there. See if I can get you into the root. Root gap is, just in case I haven't explained it, root gap is just to aid the penetration, so we can put this root right in there, and it will just give something for this to land into before we start building up around the edge there. Probably haven't explained that very well, but anyway, you'll probably understand the principle of that one. As you see, I've clamped 2 bits of angle up there. Final thing that we always do, of course, is just put our eye across it. If the eye's good, we're normally good, and to me, that looks pretty good. Prepped nicely. All looks in line. Shouldn't really pull when we tack it, so we're just going to tack it. As I say, we'll do the same to the other side, I think. So everything is prepped and ready to go, and then we can start putting the welds in. Just quickly show you this. As I say, we've just put up a half dozen little tacks around there, taking the angle away. When we just grind those little tacks back so they're flat, we just cut that TIG rod flat. I mean, it will stay in there, the rest of it will stay in there. It won't hurt at all in there. So it's the same parent material as everything else, so it'll just stay in there. As I say, that's very much a pipe fitter's trick. You see most pipe fitters, and when they're doing open root pipe, you'll see them with a TIG wire in there, clamps on it, keeping everything nice and square as they do it. I mean, they have, a lot of the guys on gangs will have actual fitters that will do all this work for them, and then the welders will just go around and just do the finishing welds. But you know, this is what we do. So that's ready. I'm going to do the other side in exactly the same way, prep them up, and then get a bit of preheat on everything. Okay, so we've put the 2 ends on, both tacked up. As you can see, we're just ground down. There's a bit of a TIG rod left in there. That will just disappear once we've done it. Both sides are done, tacked up, all looking fairly good. Fairly happy with how they're sitting. The next job is we're going to give this a little bit of preheat. Just use our old friends. Sorry, my gloves in the way. Get gloves out of the way. Just going to use my friend the temple stick to scribe this once this is up to temperature. We're just going to get the torch out, give it a bit of warmth, about 150 degrees C. near warm enough now. We'll just give it a little strive with a temple stick. It really wants to soak for a bit, but it'll give us a good idea on. And as you can see, that's nice and warm. So we're going to commence on welding on that. I think our positions are going to be, we're probably going to weld up like this. If I was using a stick, I'd put that in a proper 6G, which means that I'd be welding all the way around, but it's tricky with a MIG, and I'm going to be in spray transfer, so I'm going to be hot. So what I'm actually going to do is just manipulate it round as I do it and root into it. We actually put it onto a couple of stands now because it was just a pig to manipulate, and a lot easier like this because I can now just swing it round as I want, wedging a bit of stuff under there just to keep it in the position I want. What I've done is started working at both ends, so both ends are preheated. I've given exactly the same preheat. I just want to show you the root. Now put the root into there. One thing with a root, it's most important weld of all your substantive qualities come from the root, so you've got to put your root in right. If the root's not good, grind it out, start again. Grind out any defects, start again, etc. There's a couple of little raised spots where I've stopped and started, so I'm just going to rub around them with a grinder before I start putting subsequent passes in. But apart from that, the root's all good, so we can just keep going in and just keep running those subsequent passes over top of that root. Just finishing up these last passes with multiple welds in here. As you can see, we've ground back slightly on each stop and start. We've been a good hour or so putting these welds into here. They've got in pretty nicely. Everything looks nice and square as well. So we can, once we've got all the welds in, what we do, we just finish it off. We just dress round, and we'll show you the finished result. Right, we've finished dressing that up. We just had to run around this with a bit of emery as well. Still warm. Just where the bit of splatter got on there, but I'm pretty happy with that. That looks a pretty neat job to me, really. And by the time that's painted up, which I think is going to, you wouldn't really know that anybody's been in there, and that's the whole idea of these jobs. You make it look like you've never touched it. Okay, so proof in the pudding. As you can see, that is lovely and tight on there. Not stupidly tight. You've got a little bit of play, you've got a bit of wriggle room, get everything together so it's not going to bind or crack or anything, but they are pretty, compared with what they were, you know, that's got nothing on it. So right, we're cool at the end of part one, although that's actually probably 80% of the work done at least now on this lump. All we've got really now to do is just sort these bushes out for them, and the part is then ready to go back. So we chop this bit of material off in the saw. As you can see, it's quite nice because it means that normally what I want to make bushes up, what I have to do is weld them in and then use another piece of tight bar in between them to make sure everything's in line and squared up. Because I've got plenty of this, I can just cut the bar along for the minute, bore it out as I said before, then chop the middle out and finish the welds off. So it makes the job really nice and simple. all I've got now is to see what size the hole needs to be and whether I've got to drill the right size, otherwise I'll be boring it through. We've put these 3 bushes into place, put 2 in here, we've chopped this piece of rod down, we're just ready really to weld these in. This one's a nice tight, this one I had quite a job getting in, I had to hammer this one in. The others are slightly less sloppy fit, well this one's a lot tighter than the other side because there's a lot less wear on one side than the other. But I'm just deciding I shall probably just stick weld these in because it will give a flatter bead profile. If I go in with a MIG to keep flat bead in there, I'll probably end up with quite a pronounced finish that I'll have to grind back. Probably if I use like a 3.25 rod, just normal 60-13, nothing spectacular, and just weld these in with a stick, it's probably going to be a lot easier job for me to just do the finishing off on it. Once we put the welds in there, the whole lot is done. Okay, so we've got everything now dressed up. Just gone round with a die grinder. Here we go to see the die grinder. And a little tool. So we just flatted these back with a flat disc and then just gone in it with the die grinder just to make sure there's no burr or dross on any of that. As you can see, we've got nice tight fit now on everything. These pins and this bolt here, obviously I've had it, they've shouldered, they're worn out, so I think he's got a new set of bolts coming. But as you can see, on the good bit of the pin, we've got absolutely no play on there at all, just enough to get the whole thing assembled and together. Exactly the same on these bosses we did. So all in all, a fairly good job, which I'm fairly happy with, and hopefully the customer is. And this one, now good to go away.